Hi everyone, this is Mrs. GA, and today we're going to be proving lines are parallel. So before we're able to prove that two lines are parallel, it's important that we understand what a conditional statement and what a converse statement are. So a conditional statement is just an if-then statement. So if P, then Q. And remember, P we call the hypothesis, and Q we call the conclusion. So an example of a conditional statement could be, if the sum of two angles is 180 degrees, then the angles are supplementary. So the hypothesis would be that the sum of two angles is 180, and the conclusion would be the angles are supplementary. There we go. So now we're going to talk about what's called the converse. So the converse, what you're going to do is you're going to flip the hypothesis and the conclusion. So it's going to be if Q, then P. So again, we're switching the conclusion and the hypothesis. So the converse of this example above would be, if the angles are supplementary, then they add up to 180. So again, I took the hypothesis and the conclusion and I swapped them. So we're going to be using the converse of three of the postulates or theorems that we talked about in the previous video. So first is the converse of the same side interior angle postulate. So I want to remind you that the same side interior angle postulate said that if you have two parallel lines cut by a transversal, then the same side interior angles are supplementary. So now let's look at what they say here. This one says, if two lines are cut by a transversal, so the same side interior angles are supplementary, then the lines are parallel. So this is essentially saying, let's say I call this angle 1 and I call this angle 2. If we can show that angle 1 plus angle 2 equals 180, then we could show, let's call them lines P and Q, then we could show that line P is parallel to line Q. So this is kind of the exact opposite of what we did in the previous lesson. Now let's look at the converse of the alternate interior angles theorem. So before, the alternate interior angles theorem said that if we have two parallel lines cut by a transversal, then alternate interior angles are congruent. This again has a hypothesis and conclusion that have been swapped. So it says if two lines are cut by a transversal so that the interior angles are congruent, then the lines are parallel. So this is saying if we can prove that angle 1 is congruent to angle 2, well then we could show that line P is parallel to line Q. So again, we're using the reverse of what we used in the last video, and our point here is to show that the lines are parallel. All right, the last one, the converse of the corresponding angles theorem. So let's recap what the corresponding angles theorem was. This said that if two parallel lines are cut by a transversal, then corresponding angles are congruent. This one says the exact flipped version of that. If two lines are cut by a transversal, so the pairs are congruent, then the lines are parallel. So here, let's say we call this angle 1 and this angle 2. Those are corresponding angles. This is saying if we can show that angle 1 is congruent to angle 2, then that would show that line P is parallel to line Q. And then our reasoning for that would be the converse of the corresponding angles theorem. So we're going to see if we can use these three converse statements to help us prove that lines are parallel. Okay, so let's look at this first example. Here it says, if the given piece of information were true, would line M be parallel to line N? Explain why or why not. So we're essentially going to see if we are able to use one of those converse statements. So the first one says angle 7 is congruent to angle 6. So these two angles, we would classify them as same side interior. So if you look back at what the converse of the same side interior angle postulate says, it says that they should be supplementary, not congruent. So we would say, no, this does not prove that the lines are parallel because angle 7 and angle 6 are not supplementary. So if it said angle 7 plus angle 6 equals 180, then yes, that would show that the lines were parallel. Now let's look at the next one. Here we have angle 5 and angle 7. Those would be classified as corresponding angles. And according to the converse of the corresponding angles theorem, yes, that would prove that line M and N are parallel. Because again, corresponding angles should be congruent. All right, let's look at the next one. Here we are told that the measure of angle 6 is x plus 10 degrees, and the measure of angle 2 is x plus 15 degrees. So what we can conclude from this statement, since this one is x plus 10 and this one is x plus 2, we can conclude that angle 6 is not congruent to angle 2. Right? They both have an x. This one is 10, this is 15. So this angle is 5 degrees larger. So since they are not congruent, and we would classify those two angles as alternate interior angles, we would say that no, the two lines are not parallel because angle 2 is not congruent to angle 6. And if they were parallel, alternate interior angles should be congruent. All right, the last one says that angle 1 is congruent to angle 2. So first of all, these are linear pairs. And since it's linear pairs, we're really working only with two intersecting lines. So we don't even know anything about any of these angles or anything about line N. So this one we would say no, there's just not enough information. So again, all we know here is that they're linear pairs, and we're only working with these two lines. It doesn't even include information about this other line, so there's not enough information to conclude they are parallel. All right, let's look at this next example. This one says an overpass, which would be this, intersects two lanes on a highway. What must be the value of x to ensure that the two lanes are parallel? So we want to make sure that these are parallel. So let's see if we can look at the relationship between these two angles. So I would classify those two angles as same side interior. And according to our converse of the same side interior angle postulate, these angles must be supplementary for the lines to be parallel. So they must be supplementary, which means they must add up to 180. So let's make that happen. Let's say 4x plus 2x plus 12 equals 180. All right, so now all we have to do is combine like terms and solve. So here I have 6x, I combine 4x and 2x, and I'm going to subtract 12 from each side. And then if I divide both sides by 6, I get x equals 28. So if this x value is equal to 28, then that would make these two angles supplementary, which we can conclude would make these two lines parallel. All right, now let's take a look at example 4. So this one says use the figure over here to answer questions 1 and 2. So again, it's not enough to be able to look at a picture and say, these look like they're not parallel, so I'm going to say they're not, and these look like they are, so I'm going to say they are. We have to have some reasoning behind it. So first they're asking us, is M parallel to N, why or why not? So again, we're testing to see if these two lines are parallel. So I'm going to try to find a transversal that has angles that I know on both sides. So I'm going to use K as our transversal. So if I have these two lines cut by this transversal, let's compare these two angles. These two angles, where you see 75 and where you see 68, these would be corresponding angles. And according to our converse, these angles should be congruent if our lines are parallel. However, we can state that 75 degrees is not equal to 68 degrees. So we can also conclude from that that M is not parallel to N. Okay, now let's look at part 2. Here they're asking us, is J parallel to K? So we're considering J and K with a different transversal. So I'm going to pick M as my transversal because I know two of the angles, so one from each intersection. So I'm going to see what I know about these two angles. I can say that these two angles are same side interior. And I know that if these two lines were to be parallel, that they should be supplementary. So let's see what happens when we add them up. 105 plus 75 degrees equals 180 degrees, which means that the two angles are supplementary. So we know that if the same side interior angles are supplementary, then the two lines are parallel. So we can conclude that line J is parallel to line K. All right, let's look at this last example together. So we're going to use this same figure for 3 and 4. So first they say for AD to be parallel to CB, the value of x must be blank. So again, we have two lines here and here, and then we want to pick the right transversal. So they're asking about x, so I'm going to use AC as our transversal. So let's see what we know about these two angles. These two angles we would classify as same side interior. And we know that if we would like these lines to be parallel, then the same side interior should be supplementary. So let's create an equation where that is true. We would say 95 plus x equals 180 degrees. So if I solve for x by subtracting 95, we get x equals 85. So x must be 85 degrees for these two angles to be supplementary, which means that the lines would be parallel. So now for number 4, they want us to make AC parallel to DB. So they say, for what value of y would that be true? So again, here we're using these, and I'm going to pick a different transversal. Since we're working with y, I'm going to use AD as our transversal. So it's the same scenario. If you look at the relationship between these angles, they are same side interior, and they should be supplementary if we want these lines to be parallel. So let's create the equation. So again, 95 plus y equals 180. So y would also be 85 degrees. And there you have it. All right, so that is all for today's video. Thank you so much for watching.